is multiply both sides by v, and that will give you v squared over r is delta v divided by delta t. Now tell me, what is the quantity delta v by delta t? That must be a very familiar quantity. Delta v is the change in velocity, and delta t is the time during which that change occurred. What is delta v by delta t? Is the acceleration. So acceleration of a circular motion is v squared over r, where v is the uniform speed of the object along the circle. The acceleration of a uniform circular motion is v squared over r, where r is the radius of the circle and v is the uniform speed of the object along the circle. Very important relation. In this lesson, there are many equations I said are very important. Simple equations, but are very important. Okay, now, do you remember a relation that we established between linear speed and angular velocity? Didn't I tell you that's important? Now, how many of you remember that? What is the relation between linear speed and angular velocity? V equal to r omega. So, I can now write v squared as r omega squared over r. And what does that simplifies to? That will be r omega squared. One r will cancel. So, both these relations are important. The acceleration of a uniform circular motion, where the object moves with a uniform speed along a circle of radius r, a equal to v squared over r, equal to r omega squared, where omega is its angular velocity. Okay. Now, what is the direction of this acceleration? What is the direction of this acceleration? Well, I showed you that the direction of the change in velocity is towards the center. That means the direction of the acceleration also is towards the center. Well, that brings us to the concept of centripetal force. Now, if you look for the meaning of centripetal, centripetal means center seeking, directed towards the center. We just showed that an object moving along a circular path has an acceleration directed towards the center of the circle. The only way an acceleration can be produced on an object is that there is a net force on the object. Now, if the acceleration is directed towards the center, what is the direction of the force then? The same direction. So a centripetal force is a force that is directed towards the center. Centripetal means center seeking, directed towards the center. The direction of this acceleration, the acceleration we talked about earlier, is the direction of the change in velocity, which is towards the center of the circle. So this is the direction of the change in velocity. Therefore, that is the direction of the acceleration, and therefore that is the direction of the force that is responsible for that acceleration. So this force is called the centripetal, well, this acceleration is called the centripetal acceleration. Why is it called the centripetal acceleration? Because the acceleration is directed towards the center. Now, this acceleration is produced by a force, and we call that force centripetal force. All right, tell me, what is the equation we derived for the centripetal acceleration? A equal to v squared over r. In that case, tell me, what is the equation for the centripetal force? Well, force equal to mass times acceleration. If the acceleration is v squared over r, then the force causing that acceleration must be mass times v squared over r. So since F equal to ma, centripetal force, F centripetal is mv squared over r. Another very important equation. The centripetal force keeping an object moving along the circumference of a circle is mv squared over r, where v is the uniform speed, r is the radius, and m is the mass of the object. Now, it is the centripetal force that keeps the object in a circular path. Just like I showed you the object moving along the circular path when I was applying a force towards the center. It is that force that keeps the object in a circle. It is the gravitational force on the moon by the earth, the gravitational pull on the moon by the earth, that keeps the moon going round the earth. The gravitational force is the centripetal force. Now, the earth moves around the sun in an approximate circular path due to the force of gravity of the sun pulling it towards the center. So if this is the sun and that is the earth goes around the sun, and the force that will be keeping it in orbit is the gravitational force. The centripetal force is the gravitational force. Alright? Now, in the absence of this centripetal force, what will happen to the earth? Well, if the sun says, suppose the sun says, oh, I'm going on strike today, I'm not going to pull the earth. Well, the earth will simply move along the tangent at that position. It will go away for good. Alright. That is the direction of velocity of the earth. So if the sun stops pulling it, it will simply go away along the tangent. Okay. Now, you are familiar with a car taking a circular turn. A car taking a circular turn is continuously changing its state of motion. Is that right? If a car has to go around a circular track, it is continuously changing its direction of motion. Now tell me, when a car is moving in a circular path, what is it that provides the centripetal force to keep it in circular path? If the car has to stay in a circular path, there must be a force acting towards the center of that path. Where does that force come from? Well, that force actually comes from the friction between the tires and the road. Now, if you are familiar with traffic circles, I have lived in places where traffic circles are a common phenomenon. And if a traffic circle is not built properly, it is forever broken. You know why? Cars going round a traffic circle, the tires will be digging onto the road to produce the necessary frictional force to keep the centripetal force going. If there is no centripetal force available, the car will simply go straight. Now, has any one of you experienced that you wanted to take a turn very quickly and you couldn't do that because the centripetal force was simply not there? What happens? You will go straight onto the fence and break open the fence. If the centripetal force is not available, you cannot keep the car along the circular track. Now, if you look at the highways that are constructed properly, a highway that is constructed properly is banked. Now, what is the meaning of a banking? A banking means the outer side of the road is higher than the inner. So the road is actually an inclined plane. That means when your car is sitting on that inclined plane, let me see if I can draw that for you. Now, the road will be like this. The outer side will be higher than the inner. I'm exaggerating actually here. Now, this angle is actually called the angle of banking. Angle of banking. And this process of building a road at an angle is called banking the road. Now, what is the advantage? When your car is on this road, you see the weight of the car will be acting at right angles. And there will be a component, there will be a reaction force up. Now, there will be a component of this normal force that is directed towards the center of the circle. And it is this component that produces the centripetal force. That means a particular banking is done for a particular safe speed. On a curve that is banked for a given safe speed, if you exceed that speed, what will happen? The car will simply slip out of there. Now, in the same way, the railway tracks are banked when you are on a curve to make sure that there is enough force made available for the centripetal force. So all these are applications of how to make the centripetal force available without much cost to your tires. Well, here I have a car going in a circular track. Now, you know, when you take a right-hand turn with a passenger sitting next to you, now, don't you feel that the passenger is falling onto you? And sometimes you say, hey, keep your place, don't fall onto me. Well, if you look at that carefully, is the passenger actually falling on you, or are you falling onto the passenger? You see, the car is actually taking a turn means its direction is changing continuously. Now, you know, according to Newton's law, the passenger in the car is moving, and that passenger would want to keep on moving in a straight line. When the car changes the direction, actually it is you and the car that comes in the path of the passenger. So you are falling in the path of the passenger, not the passenger falling on you. Very important to know that. Now, according to Newton's first law, there must be a continuous force acting on the car so that it might change its state of motion. Now, let's look at the passenger and the driver one more time. Now the red one is the driver, the blue one is the passenger. Now, look at that. The red driver is actually getting in the way of the blue passenger. That is what actually happens, not the passenger falling on the driver. So this force is the centripetal force. The centripetal force is acting towards the center. Now, there are some people who talk about another kind of force called the centrifugal force. Now, if you sit in a car, when the car is taking a right turn, don't you feel that you are being thrown away from the car? Now, this is what some people call centrifugal force. And it is explained as a reaction to the centripetal force. But actually, there isn't. Centrifugal force is an illusion. It's called a pseudo force. It actually doesn't exist. Now, why do you feel then that you are thrown away from the car? If you are not fastened properly to the car,